All right, so today we're going to be covering Nix. We've been going through a lot of the nix.dev site where we went through the tutorial, the first steps. We went through the language, which was a lot of work. And what was interesting, I'm looking at like what videos you guys actually watch, and the language ones weren't so popular, but it's the one I'm most interested in. So it's kind of funny, right? It's like a lot of people just want to know how to do things. So when it's like, oh, when you're learning the language, I'm not interested. Maybe you guys already know the language, but I'm just surprised that less people actually care about that. I hear a lot of people actually like play with Nix first and then like kind of start figuring out the language as they're playing with it. But I barely use NixOS yet, and I'm starting from the language and I'm having a lot of fun. Well, that's because I love languages. Then we did a basic, this was the last video where we talked about packaging existing software with Nix, and that was pretty cool. I made a Nix cheat sheet that will be in the description of the VOD for this. And in the end, it talked about over here, I created a section on creating a package. We have like our default.nix, which has all the packages we want to create. In here, we just have hello, and we use callPackage to actually make the derivation. And so in hello.nix, we have the instructions for basically making this package. And it seems like it's always going to be a function, and whatever it takes in as parameters is what it needs to help build the package. So in here, for this one, it needs fetch zip, which is a function to fetch a zip file, and standard environment. And you can see we make use of that standard environment, make their derivation here, and we use fetch zip over here. And these are just things that you need to do to actually make the package. So that's what we did. I don't think there's more I want to add, is there? Yeah, just that call package, its job is basically to take this packages thing that it's in and then look at hello Nix, the function, and fill in from packages all of these variables, right? So inside of packages, from the Nix package, this tarball we fetched, there is standard env and fetch zip. Those are packages within Nix packages. And then we call Nix build and we pass the package we want to build. And that's based on this name here. If we had multiple names, we just pick the one that we want. All right, so if there's any questions on that, let me know. We also have a Discord server. It's in the description. You can join if you ever have any questions, because now that we're like kind of not on day 1, day 2, this is more advanced. So easily, if you're coming in here, you might be like, what's that other stuff? Go back to the previous videos. There's playlists on my channel, and you can look up like Nix, and then you'll see it from like when I start, I know nothing about Nix, and now we are doing some actual stuff. So we finished this one. Yeah, this was a little bit painful when we did it. And I didn't talk too much about the install phase and the phases and hooks today, but that's all done. So we will now just go back and start with package parameters and overrides with callPackage. So we are doing this. And I tend to just read this stuff out so that you guys can follow along if you are if you're doing this also. All right, here we are. Nix ships with a special purpose programming language, the one we learned together, for creating packages and configurations, the Nix language. Everything's called Nix, so like when you say Nix, people don't know if you mean like the packages, you know, like when you search for Nix packages, if you mean Nix OS, if you mean the Nix language, everything's just Nix. So it's kind of funny how vague it is. Um, it is used to build the Nix package collection known as Nix packages. Being purely functional, the Nix language allows declaring custom functions to abstract over common patterns. Yeah. Uh, we had a guest, Isabel, not too long ago. Um, oh, how come I have a chat but I don't actually see it on my screen? One second. Let me figure out why that is. Hello, not Mark. Apologies, I just joined the stream. What is Nix? Greets from Scotland. Cool. Let me make sure I have chat in the right um place here because I didn't see it. Show this on all desktops, show this on all desktops, and we go back. All right, I think I now see you. Yep, I do see you now on the screen. Yeah, so Nix is a programming language just like this thing said, and it is used to basically create reproducible packages. So yeah, if you want to learn more about it, go back to my series on Nix from video 1, and I know nothing about it at that point. So, but otherwise, feel free to follow along. Maybe it'll be somewhat useful. Yeah, I did a video with Isabel and doing Advent of Code with Nix. That was fun. And she did a post somewhere that was like, Nix doesn't have a documentation problem. You just need to have resources. But like sometimes I have to disagree. Like you look at this, right? And it's not easy to read. Allows declaring custom functions to abstract over common patterns. Like what are you really getting out of that, right? So I think sometimes it's not so much that it's like I can't understand it. It's more that it's somehow like off-putting in the way that like you're like I just want to move on. Why are you making my brain hurt? So yeah, I think some of this could be improved. The people who made Nix are just way too smart. One of the most prominent patterns in Nix packages is parameterization of package recipes. Yeah, that's a easy word too. Um, by the way, thinking about their choice to make Nix a purely functional language is kind of cool because, as we saw before, when in a purely functional language, when you pass the parameters, that's all it has to build or to do what it's going to do, which is really great if you want reproducible packages, right? Because you don't want to like have your inputs be something different each time, or maybe pull something from the interweb or whatever, and now you end up building something different if you're someone else and you do it like a month later. I always hate it when like you talk to your, coworker, your dev friend or whatever. It's like, "Oh, it works on my computer." It's like, "Well, it doesn't work on mine." And Docker is one solution for that, but Nix is really great, especially at the development level, because it's so lightweight and you can develop with it. It doesn't like you don't need to get a Docker container that you have to develop in and force everyone else to do the same. Anyway, overview. Nix Packages is a sizable software project on its own with coding conventions and idioms that have emerged over the years. It has established the convention of composing parameterized, I don't know how to pronounce it, with automatic settings through a function named callPackage. Right. So when we want to make packages and we want to pass options on how to build that package, we use callPackage, and we're going to see how we can do that today. What will you learn? You will learn using callPackage to invoke package recipes that follow Nix packages conventions, overriding package parameters, creating interdependent package sets. Let's not think about too much of what that is now. We can kind of come back to it. So what should you know? You should know Nix language. If you don't, go back to the Nix language videos that I did in the Nix playlist, and have some experience with packaging existing software. So packaging existing software, if you've used npm, apk, those kind of things, I guess. How long does it take? 45 minutes. Well, let's see how long it takes us. I will actually start a stopwatch so we have an idea of how long this is going to take. Automatic function calls. Create a new file, hello.nix, which could be a typical package recipe as found in Nix packages. A function that takes an attribute set with attributes corresponding to derivations in the top level package set and returns a derivation. So that's a lot of fancy words. I think all that means is make a file called hello nix. I'm going to use my Helix editor and take in make a function. So a function takes in, like all a function is, right? This is like sort of repeat for most of you, but surprisingly people don't mind going slow. I always feel like I have to go way faster to keep people interested, but I think I'm going so slow already that like anyone who wants fast has long gone. So people in here are fine with like going slow. So a function is just like takes in a parameter and then can return a parameter, right? That's a function. So if we used Nix REPL down here and we did function equals foo plus 1, maybe we don't need this. Yeah. So now we have a function f, which takes in a parameter foo, and then the body of it is on the right of the colon. So if I do f11, it's going to give me, sorry, if I do f10, my brain was going ahead. It's actually going to add 1 to that and give me 11. And then, oh dear, I'm having a hard time this morning. But then we can also pass in an attribute set like foo and bar. And then we can add those together. For example, an attribute set is basically saying these are name value pairs. So we're passing in an attribute set called an attribute set where there's a name called foo and a name called bar, and then we're going to add their values together, right? So if we copy this on the bottom, we can just make this the same thing. Foo comma bar, and then the colon means it's a function, and we add foo plus bar together. So now when we try to, if I just pass 10, it's going to say, wait a minute, I expected a attribute set. So we have to pass in an attribute set. So if I pass in an attribute set where I say foo equals 1 and bar is equal to 10, then it gets 11. So that's just a quick reminder of how functions work, because sometimes it's easy to just forget and just like, what is this arcane magic going on here, right? So what they wanted us to do was make a function that takes in one parameter, write shell script bin. And this is an actual function that comes in Nix packages, right? Because if you go to, what's it called? Noogle. And you type in write shell script bin, you'll see that it's within packages. So most of the things that you see when you're making packages, all these parameters here are going to be right under packages. Just to make that really like clear. So we just take in one parameter, and then we're going to use that function write shell script bin, which takes in, where does it show? Oh, it doesn't tell me the the stuff here because I don't think it documents it. But it looks like it takes in 2 parameters. So we're going to pass in hello and another string that is a multi-line string. That's how you do multi-line strings. Hello world. All right, so now we have a function that takes a parameter and a function as a parameter and calls that function in its body with the constant literals hello and hello world. So we will write this detailed explanation. Hello Nix declares a function which takes as argument an attribute set with one element write shell scripts bin. Write shell script bin is a function that happens to exist in Nix packages, a build helper function that returns a derivation. The derivation output in this case contains an executable shell script in out bin hello that prints hello world when run. So this is going to always create, it looks like in the out environment variable, which is set, I think, to results. You know, when we did that in the last video, this links to the results directory, and it's going to create this executable or this shell script here. In this case, I think it's a shell script. Now we create default.nix because this is just a function. We can't really run it on our own here. So we need to create a new function, write default.nix. So we're creating a new file called default.nix here. And we're just going to get our packages. So you see here what they've done is pulled from Nix packages. This is going to get the latest release, I believe. And that's not very reproducible because the latest release contains new packages all the time and updates to packages. So if you want something that's very reproducible, you go back and you use, like I copied this in my cheat sheet, you use a pinned release like this. Oops. And we indent here. So Nix packages is now pinned to a very specific version where it's committed into Git of the Nix packages. And then we import it so that we can actually use it. If you have any questions about that, feel free to ask in chat or on Discord. All right, so now we basically have this part, and now we're going to do the work, which is callPackage. Hello.nix. All right, so we save this. This is going to call callPackage, which is a function within the Nix packages, and pass it 2 parameters. One is a path to the package we want to build, right? The package build description, which is hello Nix. We just did that. And the empty attribute set, because there's nothing extra we're passing. All right, so now in order to run this, let's get out of REPL. All right, realize the derivation, which means run the executable. And the way you run this is you use Nix build. And I said earlier that you usually pass like the name of the package, like hello or something. But in this case, we don't have multiple packages we're building. There's only one here, so we don't have to pass anything. And it also knows to read default.nix because that's hard-coded. So it's basically the same as saying nix build default.nix. I think this should work also. That's right. So now it's created a derivation inside of this directory. So if we look there, Nix store, we have a bin directory there, and inside of bin directory we have hello, and that looks like we can just run it. So we can just run it like this. Oh, you know, chat's sort of like making it really hard for you guys to see. So what do I do here? Maybe I move the chat over here. I don't really know. This is complicated. I'll have to figure this out. Well, for now, I'll just put it up here somewhere. That's not good. Well, whatever. We'll stick with here. All right. So where was I? We run hello. It says no such file or directory. Uh-oh. That's kind of interesting. Result bin hello world. Why did that work? So we see here that this one calls this bash, and what I did before was nix store bin hello, and it didn't like this. Why didn't it like this? I thought there was a hello here. Let's look at this file. Strange. Oh. Wait, strange, right? It looks like it should be able to run this file. Oh, it's not finding this file. Why not? Oh, because I put in this dot. Why am I doing like silly things? There we go. I was using, it's an absolute path and I was making it a relative path. So that's just silly me. All right, so we've run it. We saw that it actually created the script in that directory and put it in our Nix store locally. The argument write shell script bin gets filled in automatically when the function in hello Nix is evaluated. Right. That just means like inside of hello Nix, this gets filled in by the callPackage function that we had in default. For every attribute in the function's argument, callPackage passes an attribute from the package's attribute set if it exists. Right, so anything in packages, right? So if we look up packages, I'm not sure what would be a good example here. In the last one we did x11. Like we can pass in xorg here, and that would fill it in over here, but I don't really know how to use xorg here. Echo, I can try to no, I think that's a bad idea. But anyway, this should still work. It should still compile. Where's our build? It'll still build, but we're not actually using xorg, but it is filled out. Okay. It may appear cumbersome to create the extra file hello Nix for the package in such a simple setup. We have done so because this is exactly how Nix packages is organized. Every package recipe is a file that declares a function. This function takes as argument the package's dependencies. So if you think of Nix packages, it's actually like, I think it is an attribute set where every package is under it. So packages.xorg, packages.standard environment. That's all. Packages.lib is all in there. That's something we could do, actually. How do we look up packages.lib? Nix packages package lib documentation. So here we have the lib function, and we have something called, like, what's trivial? ID, the value to return. All right, so in here we can pass in lib, I think, right? And then we should be able to pass in a string interpolation where we call lib.id. And what do we pass in? Anything, right? Like hello world foo. Does this actually work like this? And let's try running it. Result bin hello foo. You see, it has foo in there now. So what's really interesting is it is that these that it actually parses these quotation marks just fine. So yeah, we passed in lib here, and callPackage grabbed lib from Nix packages, and we're able to use it in here. And if I don't have this here, then when we try to build it, it will fail. So that's what that whole thing means. All right, let us continue. Parameterized builds. Change the default.nix to produce an attribute set of derivations, and that just means default.nix. We're going to make an attribute set of derivations, so there's more than one, which means we have to come up with a name for this one, because otherwise it's not an attribute set. It's like a list, right? With the attribute hello containing the original derivation. That's exactly what we did. When building the attribute hello by accessing it with the -a option, the result will be the same as before, right? So if we try to use this without any options, first we have to fix hello.nix here. Well, let's just leave lib in there, why not, right? Okay, so if we just try to build this, well, I'm surprised that it worked. Maybe because it only has one. Maybe it's smart enough that if it only has one, that's why it doesn't need the parameter. Well, we'll see. We're probably going to get to soon. Also, I think we did one before. No, I'm not gonna get us off track by testing that. All right, so now we can pass in the -a also, so we can do -a hello. Oh, it's just that I didn't save this line. I need a semicolon because it's an attribute set now, and each one is basically an assignment, so it needs a semicolon. So now if I get rid of the -a, it still works. All right, interesting. And what if I just get rid of default? It still works. And result bin hello, and it still works. Also change hello Nix to add an additional parameter audience with the default value world. So we're going to change hello Nix, and this is going to take an additional parameter called audience. So of course, audience is going to have to exist within Nix packages or something like that. And then if we don't get it, it'll default to world. Also change to add an additional parameter audience with the default value world. And then it looks like we're actually going to use that value here. Instead of typing in world, we're going to use whatever the audience is. So by default, it'll be world. So if we don't get anything, it should still say hello world. Okay, I think that's it. This also does not change the result. So if I try to build it and I run it, it says hello world. It doesn't change the result because we were typing hello world before. But if I change to hello worlds, then I have to rebuild it. And now it says hello worlds, right? So it does use it. We'll stick with world again. Things get more interesting when changing default.nix to make use of this new argument. Pass in the parameter audience in the second argument to callPackage. So now we go here. The second argument to callPackage is here. And we're going to pass in this as part of the attribute set. People. So audience is going to be people, and it says this attribute is passed on to the argument of the function defined in hello Nix. The same syntax can be used to explicitly set the automatically discovered arguments such as write shell script bin, but that doesn't make any sense here. So what that means here is that audience we're going to be passing in, and then over here it's going to use that audience and fill it in over here. It's also saying that we can pass in what is that other function called? This one, write shell script bin. We can pass that in here also. Write shell script bin equals something else. and that will override the function write script bin. But we shouldn't do that because this is an important function. We shouldn't rewrite it. But it's a cool thing to know we can do that. All right, so now if we run this, we have a new build. We run it, and it says hello people because it's using the audience from up here. How's this going for everyone? Okay, I'm gonna hide chat actually, since it's not very active. Where are we? This pattern is used widely in Nix packages. For example, functions which represent Go programs often have a parameter build Go module. So that means over here, well, it actually means over here, maybe we pass in build Go module. Yeah. It is common to find expressions like callPackage Go program.nix build Go module equals build Go 116 module to change the default Go compiler version. I see. So this is specifying which Go version, compiler version to use. Nix packages is therefore not simply a huge library of pre-configured packages, but a collection of functions, package recipes for customizing packages, and even entire ecosystems. For example, all Python packages using my custom interpreter on the fly without duplicating code. Yeah, so it's saying we can configure how we can personalize kind of how we compile a package, which is really cool, how to build a package. And some of these things don't have to be like compilers or stuff like that. They could actually be configuration options that get like saved as a shell script or in a config file later. So there's so many ways in which you can kind of configure a package for your use. And I guess I haven't gotten there yet, but that's probably why, NixOS configs are so cool, because you can define, I want this program and I want all these other things that you can configure for them. Like how my editor, which like language server protocols it comes with for my editor. Overrides. callPackage adds more convenience by allowing parameters to be customized after the fact using a return derivations override function. All right, let's parse this a little bit. Allowing parameters to be customized after the fact. I see. So we already used callPackage, so we passed in the parameters, and now we're able to do it again after we actually called callPackage. I think we'll see that in a second. Add a third attribute, hello folks, to default.nix and set it to hello.override called with a new value for audience. All right, so here we have hello folks. And this is basically going to be using hello, this other attribute that's here. And since we're using an attribute that's already existing in our attribute set, we have to declare this as a recursive attribute set. And we call hello.override. So whenever callPackage, I guess any derivation probably has an override attribute, and then or that is a function, and now we can call that and pass it new stuff, which changes how it's built. So it's basically saying make a copy, I guess, of hello, but change audience to folks. Even though over here you said it was people, change it to folks for this one. So it's just making a copy and changing it. It's a little bit like having a map and changing a value in it, right? Changing a key value pair. Okay, so I assume I can save this now. And then now I shouldn't be able to just run nix build because it won't know what to do. I think it just builds everything. I see when you do this. When you do this, it builds everything. So one of these is probably the hello folks. Let's see this one. Yeah, hello folks. And this other one is hello people. Hello people. Hey, we figured it out. So if we just want to build one, that's when we say -a. Hello folks. I think this should work. Yeah, and that just gives us the same one here, right? I38, I38. All right. The resulting attribute set is now recursive by the keyword rec. That is, attribute values can refer. Yeah, because we need to call hello in this attribute value. So it's going to be self-referential. Override passes audience to the original function in hello nix. Right. Override passes audience to the original function in hello nix. Right. So we're passing a new audience to the function that was created from the original callPackage. It overrides whatever arguments have been passed in the original callPackage. So we can change any parameters that were called in the original one. It could probably even change like the lib, right? It can change lib to be something else that produced the derivation hello. All the other parameters will remain the same. This is especially useful and can be often found on packages that provide many options to customize a package. All right, cool. Building Hello Folks attribute and running the resulting executable will again produce a new version of the script. We did this, and it did. A real-world example is the NeoVim package recipe, which has override arguments. You should say has had if you really want to do like the past, but I think it's just a typo, which has overrideable arguments such as extra Lua packages, extra Python packages, or with Ruby. Should we take a look? Here is NeoVim. Here's the source to build this NeoVim unwrapped target. You see it's passing lib, it's passing lib, standard, environment, fetch, all of these things that it wants to use from packages. And let's see, what did it say here? It said extra Lua packages. So do we see extra Lua packages somewhere? Oh. Extra Lua. I think they're lying. Lua. Make derivation stand Lua packages if Darwin, then Lua packages override attributes. It looks like it is overriding stuff, but not the same way that we were doing it, because it's calling override attributes and not override. So I don't think this is the best example that they could give. Lua on build override, and they're changing like some of the values. Codegen Lua equals. All right. Well, it's pretty cool. There's like all these options on how it's going to build Lua based on parameters and stuff like that. So it passes override so that it can customize it further. All right, we're going back here. Interdependent package sets. You can actually create your own version of callPackage. This comes in handy for package sets where the recipes depend on each other. All right. The following examples do not show the called files as they are not necessary for understanding the principles. So I think called files means they're not going to show A, B, C, D, E, Nix, just like what we would call the default.nix that lets us build this. So here we go. We have this file, which I feel lazy, but I will actually type it. So we get rid of this stuff, or maybe we just comment this out for now. And we have packages.callPackage. A.nix. Here we go. And I guess I could just like change this here. So this is B. Oops. This is C. And this is D. And this is E. And the same thing here. Hi. Hey, Isabel. Here, Isabel says hi. So there's Isabel. Hi, Isabel. I talked about you. Did you hear? You missed it, I think. And then we fix all of these. All right, and we have to change some of this stuff here. Inherit a. Nope, just got here. Yeah, so we did talk about you. Because I said that you mentioned in one of your skeets or whatever how Nix doesn't have a documentation problem. It has a resource problem. And then I was reading this part here all the way on top where it was like, where does it say this? I think it's just one of these sentences here for creating packages. Being purely functional Nix package, the Nix language allows declaring custom functions to abstract over common patterns. One of the most prominent patterns in Nix packages is parameterization of package recipes. It's not like I was saying that it's not like you can't understand it. It's just that like it's not very friendly language, right? And you're just like, what are they trying to tell me? If I don't fully understand it, like, is this too smart for me? That's how I'm always feeling, you know? So I don't think it has like a lack of documentation problem, but I think it has like, can we bring the language down a little bit so that mere mortals like me can read it pretty well without having to spend half my brain cells? Such needlessly big words. Exactly. For real. So, where are we here? So we have these call packages and they are interdependent because B is basically B is going to inherit all of A. And as we've learned in call package, anything we pass in here in this attribute set is going to override, is going to be overriding or passed into the call package. So if A produces stuff, right, like it's going to now, whatever A produces, it's going to be usable within B. And so now we have a graph that's basically B depends on A, C depends on B, D is on its own. It's like, you know, all free. But then E depends on C and D. So you have this like chain of things that depend on each other. It's the kind of explanation that only makes sense when you already understand exactly. And these aren't like reference manual. These are like in the tutorial section, guys. Like this is like a common experience I have in the tutorial section where it's just like I think they're like reviewing for people who already know it. Yes, Nix is great if you know it already, and if you don't know it, well, sucks to be you. So where are we now? Here, inherit A is equivalent to A is equal to A. Right, so in here we could rewrite this. It just means that we're passing the package into B. Okay, I can't run this because we don't have these derivation files, but it's trying to make the point that if you set this to recursive, that call package can depend on one another. Previously declared derivations are passed as arguments to the other derivations through call package. That's what we see here. In this case, you have to remember to manually specify all arguments required by each package in the respective Nix file that are not in Nix packages. Right, so Nix packages, as you know, will already have stuff like packages that have already been built, like the Xorg, X11 stuff, and it has the libraries and standard environment. But if you're, making something that is not in Nix packages, then you have to like pass it on in here within the inherit statements. If b.nix requires an argument a, but there is no packages.a, the function will produce an error. Yeah, so it can't find it. This can become quite tedious quickly, especially for larger package sets, right? I guess because you're always having to type inherit A, inherit B. Sounds a little bit like complaining, though. It doesn't seem that hard. Use lib callPackage with to create your own call package based on an attribute set. What do we have here? Haskell has a similar problem. Well, Haskell doesn't seem to even have like Nix and Rust have documentation you can easily get to on their main page. If you go to Haskell, I don't think you really, they don't, is there like a Haskell book? I don't think there's a Haskell introductory. Yeah, I think as far as I know, they basically tell you to go somewhere else. And there's not like there's not like the Rust book, the book. There's not the Nix documentation. So all of these just have different issues, and the open source versions aren't always the best. And yeah, that is sort of a Haskell problem. Custom call package with is coded. Is it? I think I use Nix quite a bit, but never to actually build packages. So I'm an imposter Nix user. Use lib callPackage with to create your own version. Let's take a look at this. How does this work? So we have a new let here where we have our own version of callPackage. And we're using packages.lib.callPackage with. So that's where we are, that's where we get the function. It's in lib. And now we're going to pass it packages. And this operator is the merge operator. It merges attribute sets. So I think if we do like a is equal to attribute set foo equals 1, bar equals 2. And then we have another one here where we have bar equal, well, let's just make it another one. Day equals 26. And yeah, let's just make it like this. Time is equal to, what is it, 14 hours now. So we have this and we have this, and I think if I do AB, it just merges the two together, right? But now if I have one that will override it, I think that will work too. So if I have B is equal to bar is equal to 10, now you see bar takes B is merged into A but overrides values in A. So now we have everything from both, but with B taking precedence basically. I abuse lib call packages with and from directory recursive. You sound so excited about it, but it's like, this is like, it's not, I mean, yeah, I guess. Maybe you're just an abuser in general. I think that's probably more it. Okay, so it's going to take packages, which is this packages up here, right? And then it's going to merge this packages, which we haven't written yet. So we're going to write this packages. Packages is equal to, and Here we go. Oh my God. A equals call package a.nix with nothing. And then we just do this a few times. B, C, D, E. And then we put A, B, C, D, E here. And now we need a semicolon. So it has all of these call packages, and it's going to merge them into packages. Oh, I see. It puts it into our package, into packages basically, so that it becomes available for the next call, so we don't have to pass it along. Oh, I see. I see. All right, just in case this isn't clear. So, well, the documentation probably explains it too. So let's just go on with the documentation, and then I'll go back if it sounds bad. All right, so here is the file. I think that's correct now. And this is replacing how we had to do call package over and over and over again. But I mean, Isabel, we have this here. Like, it's still, we're typing it, you know? Um, it, it's just that we don't have to type inherit. That's the difference. First of all, note that instead of a recursive attribute set, the names we operate on are now assigned on a let binding. So it's saying that this is no longer a recursive attribute set. It's just a package inside of on the let binding side. It has the same property as recursive sets. Names on the left can be used in expressions on the right of the equal sign. This is how we can refer to packages when we merge its contents with the pre-existing attribute set. Right, so it's saying that within a let thing, we can refer to other parts in let, right? So should I make an example of that? Okay, so we'll have a equals 1, and then here we can just do b equals a plus 1, and then we have in just b, right? And what is this called? Nix instantiate eval strict let.nix. Right, so you see that it added these two numbers together, and if I made this 9, then it will be a 10. So it's just saying that within a let, you should be able to call each other in any order. So you can see I can call A even though it's defined later. So let's go on. You know, it's so weird that I swear that half of the people that actually watch these videos are people who already know this stuff, and they know it way better than me. So I think, you know, here's my theory. I think it's basically that this is painful to learn, right? So when something's easy to learn, you don't care, but this is painful to learn because the docs need some work. So when you get through it and you feel like I've learned it, then you watch someone else trying to figure it out and like, oh, suffering a little bit. It just makes you feel better. It's like, oh, I've arrived. Just, this is all just you guys feeling better about yourself. Come on. No, you can keep watching. I want you to keep watching. Okay, same recursive properties. This is how we can refer to packages, right? That means over here, we can refer to packages, this thing, even though we've defined it later. That's what they're saying here. And so your custom call packages now makes available all the attributes in packages and packages, the one that comes from the Nix itself and the one that you made, to the called package function. The same names from pack. How much wood can a woodchuck chuck if a woodchuck could chuck wood? This is this could be a little bit easier, guys. Like you're just saying packages 100 times, but I think we get it. Um, yeah, this last bit may make your head spin. Yes, it does. This construction is only possible because the Nix language is lazy evaluated. Elizabeth, we had this discussion. You see, even they're saying it's lazy evaluated. It's lazy. It's a lazy language. That is, values are only computed when they are actually needed. It allows passing packages around without having fully defined it. Right. Each package's dependencies are now implicit at this level. What's this level, right? I think they're just saying like when with our call package. They are still explicit in each of the package files. Right, okay. And call package resolves them automatically. So I guess it's saying that these things like the Nix packages doesn't have everything in the world in one package, I'm guessing. It refers to other files, and that's why it doesn't have to be humongous. And it's only when you actually evaluate the sub package, the attribute within Nix packages, that it actually needs to evaluate them, which is probably when it loads the file into memory and does all the work, right? This relieves you from dealing with them manually and precludes configuration errors that may only surface late into a lengthy build process. So just to try to make sense of this, so what's happening is package will actually make call package for all of these individually, right? But then this call package with is going to pull in each of these into the Nix packages so that A and B and C and D and E are all available within within like basically how we use PKGS, right? So that means that if they're interdependent, one depends on the other, they will have access to it. And the reason this can work is because it's lazy evaluated, right? Because it has a reference to it, but it doesn't actually have to evaluate and put it in there. So you don't have like circular definitions or anything like that. So that's pretty cool. My understanding is that call package looks at the argument attribute set, resolves each of the names in that, each of the names and executes the function. It's going to call package. We don't have the old one anymore, right? But what call package is going to do is the parameter after call package is the path where there's a function that needs attributes, and it's going to pass those attributes to that function. It's going to basically fill them out based on what's inside packages where it is, right? So here we're just kind of changing call package to actually include more things, which are all of these packages that we're building. But I guess like their point is it's automagic. If you just know that you have dependent packages, you can use this form where you merge your packages with their packages, and you have a new call package function. Of course, this small example is still manageable in the original form, and the implicitly recursive variant can obscure the structure for software developers not familiar with lazy evaluation, make it harder to read for them than it was before. But this benefit really pays off for large constructions. This is what you guys are telling me, where it is the amount of code that would obscure the structure and where manual modifications would become cumbersome and error prone. Okay, great. Summary. We're like done. We took longer than they said. Silly question. Why are you doing it this way instead of using overrides or overlays? You make it sound like I came up with this documentation. I didn't. I'm learning Nix, which means I have a set of videos where we just go through this, and we're here now. So I'm not like, hey, I'm trying to do something. What's the best way to do it? I'm literally. You should ask the Nix folks uh, why they do it this way. But basically, overrides is because we read about overrides earlier, right? Here are overrides. Overrides basically will take an existing derivation like this one and change the inputs that it gets, right? Uh, and and that is different than having building different packages and having one depend on the other, right? Because they now you're not just changing what parameters they're getting in, they're whole different packages. Thanks, Isabel. I don't know what you said because I don't know what overlays are. Is that something we learn soon? I don't think overlays exist. It's not mentioned here. Where's overlays? Maybe it's in working with local files. Anyway, summary. Using callPackage does not only follow Nix packages conventions, which makes your code easier to follow for experienced Nix users. This is the key, experienced Nix users. Nix is great for experienced Nix users, but it also gives you some benefits for free. Parameterized builds, overridable builds, concise implementation of interdependent package sets. Right. So the guide might not teach you about overlays since they're pretty weird. That's is that like a technical term? They're pretty weird. References, Nix packages manual, callPackages with, we did that. Next steps, working with local files, learning to, I don't know if you can see this here. Learn to package your own projects with Nix. Yay! That's going to be so fun. We're going to be able to make our own stuff and then we'll pollute the Nix packages with all of our little pet projects. Is there like who approves Nix packages? Like if I make a silly program and I make a repo on GitHub for it and I want to add it to Nix packages, will they just add it? Or does someone say like, dude, you need 20 stars? Module system deep dive. Learn to wield the functional programming magic behind NixOS. What? Doesn't this sound too this sounds too attractive, too tempting to not do. Where is this from? Wield. This is like playing Dungeons and Dragons or something. No, we don't like. This is like playing Pathfinder or something. We're gonna wield some magic. I want this. System deep dive. I love deep diving. Oh my god. And it's long too. Look how long. You know how long this is going to take us to get through? This is like going to be this is going to be like 24 videos. Well, I doubt it, right? Because some of these are really short, but this is long. This is going to be fun. I'm so excited. I don't even know what it is, but I definitely know I want to wield functional programming magic. Uh Nix packages manuals. Also, there's no minimum requirement. Really? If you make friends with a Nix packages committer and they're willing to approve your PRs, you can do more or less whatever you want. Oh my god. Do you guys have like some kind of contacts, some leads. All right, so I think we're gonna end with Nix here. This will be part of the VOD, so if you're watching the VOD, if you like this video, please do like and subscribe. I usually stream also, and that's how I make these things, so you can get notifications of those. There's also a Discord server you can join. Thank you.